In this video, we're going to look at an example of a probability density function that's given to us as a piecewise-defined function. The setup here is the probability that an amount of REM sleep during the first 4 hours of sleep is described by this particular probability density function. So it's defined as 1 over 1600 t, where t is between 0 and 40, and 1 over 20 minus 1 over 1600 t if t is between 40 and 80. So the first part asks us to find the probability of the REM sleep being between 30 and 60 minutes, and the second part asks us to find the mean. So again, when we're asked to find the probability that we lie between two numbers, we do the integral between from the lower number to the upper number of the probability density function. In this case, we'll do from 30 to 60 of f of t dt. Notice that f changes definition at 40, so I have to split this integral up at 40. From 30 to 40, the definition is 1 over 1600 t. From 40 to 60, the definition is 1 over 20 minus 1 over 3200 t squared. Oh, excuse me, 1 over 20 minus 1 over 1600 t. I was off the line when I was looking. All right, so here is the two definitions for f, depending on what interval you're on. Antiderivative of the 1 over 1600 t is 1 over 3200 t squared. For 1 over 20, we get 1 over 20 t. And then again, we just said what we got for the 1 over 1600 t. Plug in our endpoints. That's on this line. Simplify your arithmetic, and you get 19/32. For the mean, remember, we're going to integrate over the entire region, in this case from 0 to 80, of the variable times the probability density function. Again, the probability density function is defined in two pieces, so we have to split it where it changes definition. So that's what we've done here. So from 0 to 40, we use t times 1 over 1600 t. From 40 to 80, we use t times 1 over 20 minus 1 over 1600 t. Distribute your t through. Well, here we just have to multiply. Here we have to distribute through. First one we'll have 1 over 1600 t squared. That's from 0 to 40. For the second one, we'll have 1 over 20t minus 1 over 1600 t squared. That's from 40 to 80. The first integral is 1 over 4800 t cubed. The second one is 1 over 40t squared minus 1 over 4800 t cubed. Plug in our endpoints and simplify, and we'll get that the mean is 40. And if we go back and would have graphed these things, I don't have the graph on here, but you can see that this thing's going to go up as a line, and then it's going to come to a peak and go down, and it's going to be symmetric around 40. So if we would have looked at a graph, we probably would have been able to guess that the mean was going to be 40 to start with.